So again, continuing with the series, this is next lecture in the series, and what we discussed so far was about the active elements and the passive elements in the electrical circuits. As said, the active elements are the ones which are supplying the current or the energy to the circuit, which are the current and the voltage sources, and the passive elements which we discussed were like the resistance, inductor, and the capacitor. And when now we are going to talk about the DC circuit theorems and the current laws, which are the Kirchoff's current law and the Kirchoff's voltage law. That's the main two laws of which will be used to solve any electrical circuit. So we will consider the case of only DC circuits, and in the DC circuits we will consider only resistance. So the current and the voltage in the DC circuit are constant, and the inductor and the capacitor will not come into picture. So the first law which we will discuss is the Kirchoff's current law. So this says that whenever any three current carrying nodes, whenever three current carrying conductors or current carrying elements of an electrical circuit will meet at a junction. Suppose this is a junction where when different elements like two or more current carrying elements are meeting. So this is a circuit, so all the elements of the circuit will be closed, and the element which is shown here will be carrying the current I1, and the element which is showing here will carrying I2 and I3. So this could be a resistor, it could be a conductor, or anything. So we are talking about the DC circuit, so it would be mostly resistors which would be supplying, through which these currents will be flowing. So the point at which two or more conductors will meet or two or more elements will meet is known as a node. So this node, at this node, if you apply the Kirchoff's law, it says that the current coming towards the node, that is this and this, will be equal to the current which is leaving out of the node. So that is the I1 plus I2 will be always equal to I3. So if you are bringing the I3 into this side of the equation, it will become minus, and it can be written as I1 plus I2 minus I3 equal to 0. So this is what is known as the Kirchoff's current law. And the next law is the Kirchoff's voltage law. So the Kirchoff's voltage law can be applied to any electrical circuit, and the electrical circuit, as said, it would be closed. And when you will apply the Kirchoff's voltage law, it says that the sum of the voltage sources in any circuit to the voltage drops in the circuit, that is this and this, the voltage drops will be always equal to 0. So that if you will go from start from this circuit from this voltage source, and if you will go in this direction, and if you will come back to this direction, so you will come across the voltage source. This is a 1 voltage source, and this is a 2 voltage source, and there is a voltage drop here. This is a first voltage drop, this is a second voltage drop, and this is a third voltage drop. So the sum of the voltage sources and the voltage drop will be always equal to 0. So if you are, so what is the convention here is that whenever you are moving from the negative to the positive, it is, you are taking it as a negative sign. So there is a rise in voltage here, so it is taken as a negative. Again there is a drop in voltage here, so it is taken as a positive. So the voltage drops are in the circuit are taken as positive, and the voltage rise is taken as negative. So you are moving in the direction of the current always, so the current is flowing in this direction. So again this is a positive because there is a voltage drop here, and again if you see, the current will move in this direction. So whichever direction the current is flowing through the resistance, it will always move from the positive to the negative. And again you are coming across another voltage source, but in this case you are moving the direction of the current, and it is moving from positive to negative. So there is a voltage drop here, so this you will take again positive here instead of negative, and finally you will come across this. So the sum of all this will be equal to 0. And again if you will substitute it as I1 R1, so I is a current flowing through a circuit, and R1 is a resistance, again the I R2, and then there is a VB which was the voltage drop, and IR3. So it can be written as VA minus VB is equal to IR1 plus R2 plus R3. So this is simplifying the equation, but this is a main equation which can be written from the Kirchoff's voltage law. So these are the two important laws which can be used to solve many number of electrical circuits, or to simplify and to solve. Suppose you are given a circuit and you are asked to find the current, or you are asked to find the voltage, etc. So you can find that by applying the Kirchoff's current law and the voltage law to simplify the circuit. So that's also these, but it is found that by you, so if you, this is a simple circuit, so it was very much easier if you to find the voltage and the current through the Kirchoff's current law or the voltage law. But when you are talking about very large circuits and complex circuits, in such case you will need different theorems to solve the circuit. So there are different network theorems, like the mesh analysis, the branch current analysis, or the node analysis, and the Thevenin's theorem, and the Norton's theorem, or the superposition theorem. So these theorems will help to solve the circuit in a quicker way. So we will discuss about the different network theorems for DC circuits in the coming lectures. That's all. If you like this video, please do subscribe, like and comment.